My name is Anurag Patel, and I'm the open source developer behind XRP Scan. It's an explorer for XRP Ledger. Now, the title of the talk is a deep search platform. Now, what is deep search? In my views, in my opinion, it is the ability to search for a transaction using one of the 106 main parameters, main fields in a transaction object, and as well as the metadata which is available in a transaction. Now, why do we need deep search? As you know, when you go to an Explorer and you view an account, you'll be able to see the transaction listing and whatever Explorer you use, and you can usually do a next, and see the transactions. But what if we are looking for a transaction made 6 months ago? It's pretty difficult using the explorers right now. I think the limitation is because the data source, RippleD, Clio, does things in a paginated way. You have to view an account and then say next, and if you want to scroll back to 6 months, it's almost impossible. Like a big exchange like Coinbase, which does hundreds of thousands of transactions a day in and out, it will take a week to go next. So this is a question which was asked on Twitter a couple of days ago. Is it possible to look up an XRP address which contains a destination tag? XRP wallets, especially the ones which are multi-bus, which are used by exchanges, they have two fields. Like when you're sending to a person, you have an account, and you also have a destination tag. It's not possible right now in a very easy way to see like funds sent to a destination tag. You can see an account, and you have to say next, and find out which destination tag it is. So, like, this is a question which was asked. This is another question which was asked on a support email address. Like, I want to do a random search based on various transaction types or various fields which are there in the transaction. Do you support it? So this is two examples I'm giving. Like, but a lot of people have asked to be able to search transactions from the entire XRPL full history which is available. So it's using this platform. This is an API only right now. We'll talk about it. It's possible to search for transaction using source tag, destination tag, which is one of the most common questions. Using account and destination, using amount. Let's say I want to search for transaction which has 11 to 12 XRP, which I sent 6 months ago. I don't know what the hash is. Can you search it? And any of the other 106 transaction fields. Now, I'll just cover briefly what is Kafka. This entire platform uses something called as Kafka for stream processing. Think of Kafka like a river. Those who already know Kafka would understand this, but think of Kafka like a river. One of the streams is the ledger stream, wherein all the ledgers are coming in. If you know RippleD has many streams like ledger, transaction, validation, manifest, and many others. So think of like a river which is flowing and all the data is getting generated. So you try to listen to these streams and start indexing them. Next, I'll cover the architecture. So RippleD is there, and full history node is there, two big sources of data. RippleD, as it is running, it doesn't store entire history. It does a forward transaction processing, and full history is where everything else is. So the two different data sources which is supported, and it uses a consumer and producer model. That's how Kafka works. So consumers are the ones which are at the bottom. They consume data from the river, and the producers are the ones which put in data. So data can be a ledger. In this case, it's mostly transactions. And you have the three streams which were mentioned in the previous slide, like the rivers. The events, validations, the ledger. This, as the ledger progresses forward, this is generated every 3.7 seconds. And at the bottom, you see that's a data store, Elasticsearch, 8.x I'm using, and which provides the search and query capability using a REST interface. Running in your environment, it is an open source project, so you can go to GitHub page, and you need access to a RippleD or a Clio instance. You need Elasticsearch. it's fairly easy. These are like, if you're using CentOS or Fedora, you can simply get the RPM and install it. If you have Docker, it's very easy to install the Zookeeper and Kafka. Or else, if you have the RPMs, just go ahead and install it. Just make sure that you have the usernames configured, port numbers have been saved somewhere. And for this, you need about, I've not indexed the entire full history, but you need about 8 terabyte of storage. Fast storage is good, NVMe storage is very good. And the code itself is written in Go, so if you have Go compiler, you'll be good to go. So I'll briefly show how you can run it. You can see the font is good enough. So this is repository I've already checked out. Just say make, that should build your binaries. .bin / platform server. This will start running it. I'll just briefly cover the environment variables which you need to modify. .env.example. But these are the environment variables. Is it visible? Yeah. So WebSocket URL is where you'll be listening from this RPL, and the full history is where you do backfill. So I'll cover that backfill as well. And most stuff is already pre-filled. This is an example file. This is the refresh interval. Elasticsearch does real-time indexing. Every 3.7 seconds, it will create new transaction, it will insert it. And this is setting, let's say, if your disk is slow or you're using EBS, something else, you can control how frequently, how real-time you want the data to be. You can make it for 3.7 seconds or 5 seconds is the default. And if you want to do a little slower, so every 60 seconds you want to refresh the index so that it's searchable, queryable, you can modify that. Rest stuff you can customize. So simply say bin / platform - server, and it will do ping and start indexing. And it's in debug mode, so it'll tell you how many validation transaction. So as you can see, 1 ledger is indexed, 35 transaction index, 18 transaction, 35 validation. So it will keep on indexing and show some statistics. It's in debug mode. But this is the forward indexing. Next is backfilling data. There's also a platform CLI, which is for configuring the instance, configuring the platform. So it has a backfill command wherein you can specify the ledger range that you want to index. So usually, so forward is from today, right now, to 88, 89 million ledgers which are going on. But if you want to backfill from full history, you can do that as well. I'll quickly show how that works. Yeah. Bin platform CLI. From, let's say I want to index from 1 million ledger to 0. Only 10 ledgers, right? And we'll make it verbose. That should pull in from XRPL cluster full history node and index it. There's another command available to see what's already there. EPS. Okay, that should print what's already available. I have indexed from 51 million till 88 million, and approximately 40, 50 million transaction every million ledger. And the size which is consumed is between 45 to 54, 90 GB. Depends on how busy that particular millionth ledger was. If you remember, around January, February, the transaction volume spiked from 1 million every day, it spiked to 5 million. So during that time, the disk usage spiked to 167 GB. This is the 85 millionth ledger. So it indexes transactions in buckets of 1 million ledger to avoid deletion of data. Let's say we discover a bug later on, and you want to delete the ledgers. So instead of deleting everything, you could simply narrow down which ledger you want to delete and then clear the bucket. Coming to search queries, like what can it be used for? This is simple search query built in using Elasticsearch DSL. And to answer the first question, which someone on Twitter asked, can you search accounts by destination tag? So using this DSL, you can say query bool must, the transaction must contain destination is, this is a Coinbase address, if you know this, Coinbase address, and destination tag should be 0. So as you know, XRPL uses destination tags, and it has to be an exact match. It's an integer exact match, or else it will go into the common wallet and not retrievable, because Coinbase or any exchange will not know who to credit it to. So it's very important we put the right transaction data, destination tag. So in this case, 0. Let's find out how many transactions Coinbase received which had destination tag 0. Okay. I have prepared the search query already here. The same thing. I'll make it 0. Sorry. Okay. I've overridden xcurl. It uses curl in the backend, but it also adds the Elasticsearch username and password. So just think of this as curl -x-u elastic and -p and everything. This abstracted out. So xcurl -d is this JSON. I'm posting it to Elasticsearch index, and I want to search in the bucket, which is 88 millionth bucket. So all the transactions which were closed in 88 millionth ledger. Press enter, and you immediately get the result. And this is an example. This is the address that we're looking for with the destination tag 0. So using this, a user or exchange or wallet provider can instantly identify which transactions are there, but they're like unable to locate it. So using this, it's possible.
1 million feet.
What's that?
He paid 1 million feet.
It drops, yeah. So probably 1 XRP. And it shows the last 10 transactions. This is also the same thing, transaction destination 0. Let's try something else, a little more complicated. Search 2. So this one is a transaction which is sent from Uphold. That's the Uphold address, outgoing address, and sent to Coinbase. And it says must match account this, must match destination Coinbase, and must have a range, which a delivered amount value should be between 11 to 12 XRP, inclusive of both ends, like GTE greater than or equal to 11 XRP and 12 XRP. So to answer the question, I sent 6 months ago, I've not added date, but yeah, let's assume 6 months ago, I sent between 11 to 12 XRP from my Uphold wallet to Coinbase wallet, but I don't have the transaction hash, and I'm unable to claim it because it went to destination tag 0, so I'm unable to claim. I need the hash. So if you get this kind of question, it should be possible to answer it. Search to the JSON. Okay, so these are the transactions. This was sent from account from Uphold and sent to destination Coinbase, and delivered amount is this one. This is 11 XRP. So it's between 11 to 12 XRP, I can now locate. Using the same principles, you can use a date timestamp. So between certain date or certain date, you can, in a UI, you can provide a date selector and narrow down transactions and show, search what you want. Okay. Detecting anomalies. Yeah, sorry, go ahead.
Sorry, quick question. So in the case of objects that are created by accounts, like let's say escrows, right? Or is there a way to search and see all escrowed XRP, or do I need to know the accounts that have created the escrows or the destination accounts for the escrows?
Right. It should be possible, although not directly. What you're probably talking about is the ledger objects. Right. So the way it is implemented right now, it only indexes transactions, but it can be extended to also, by every time a ledger closes, there are about 14 million ledger objects right now with every ledger. So should be possible to index them and watch as the objects are mutated, update the index as well. So those objects, it should also be possible to index it, although it doesn't support right now. Next question is detecting anomalies. Now again, going back to the January to February period when transaction volume spiked to 5 million, and like validators and interested parties were trying to address like what happened, why the transaction volume spiked, which are the accounts responsible for creating all these transactions. So it's an anomaly, right? Because you don't see a lot of value being transferred, but the transaction spike is there. So what's happening? To answer the question, you can do something like a significant term search in Elasticsearch. This is an Elasticsearch feature, wherein it tells you between the background, which is the 88 millionth ledger, or whichever ledger in the bucket, between the transaction in the background and the foreground, which is the query that you mentioned, transaction type payments. So what is the anomaly? What is the anomaly? Which account was responsible for creating all these transactions? So this will answer, given the background 88 millionth ledger and all the payment transactions, which are the accounts which are responsible for maximum transactions? I have prepared query in anomaly.json. So it will take a while, and it will tell you in 88 million ledger, this was the account which sent the maximum number of transactions. It's about 11 million, I guess, 1.8 million, 1.1 million. And this is top 10 accounts which were responsible for generating transaction volume. Another example, this is Coinbase wallet again. Coinbase wallet, which destination tag received the maximum amount of funds? So it generally, there are a lot of accounts which sent micro transactions of like 1 drop or 2 drop, which increases transaction volume. So which is a specific destination tag which received the maximum number of these micro transactions? So second prepared query, anomaly 2. It'll take a while, and it will tell you these are the destination tags in Coinbase that received 1,534 transactions is the maximum. So this way you can create your foreground and background and find out which are the anomalous transactions that can show up. This is some numbers. The full history is, last I checked, it has crossed 30 terabytes. I guess it's 36 last year, but I think 30 is a safe number. And in the platform, I'm trying to index, like I've indexed about 31 million ledgers and all the transactions within it. So backfill is still ongoing as we speak. I think 50th million ledger I've started, but yeah, another 50 million ledgers to go. This many transactions already there in the index, 1.7 billion. And storage is about 3.5 terabytes. The difference is because I have removed meta.affected nodes. For answering these kind of questions, affected nodes is a property which tells you how the objects are mutated, which may or may not be very useful right now. So in the interest of saving disk space, I've just removed that for now. I estimate that if I index everything, all the 88, 89 million ledgers, I may touch 6 or 7 terabytes of data, which is manageable. And I guess using this open source code, anyone can run it on a single node and answer the questions. XRPL Go is a library which, this project is in Golang, so this is a library which I extracted out. And if anyone is developing in Golang, please try it out. It's a client library, so it does the WebSocket interface. It doesn't have the account lib and the binary codec and account codec, but everything else that you want to use to read the streams or query the ledger using Golang, please try it out and let me know if I can extend it or help with anything. Yeah, and that's the last slide. Thank you.
Have you considered dumping all the data in just an old-fashioned SQL, PostgreSQL database? So you can.
I haven't, because PostgreSQL provides a good aggregation facility also, but I wanted to address the anomaly detection capability, which Elasticsearch is very good at. And right now, for the main explorer, I'm using the MongoDB database, and wherein you have to define the indexes and create them, which takes additional space. Again, depends on how the queries are coming in. You have to choose which indexes you want to create. With Elasticsearch, I get that for free because everything is indexed, and things like the memo data. Memo data is full text, and it indexes for free. So I want to try that, and especially the anomaly detection. I have only few use cases right now based on the questions which have come in from Twitter and support tickets. But this is why I tried Elasticsearch instead of a relational database. No specific reason, just curiosity.
Are you thinking of having a UI for this, similar to BitHumps?
Yes. Let me show React Query Builder. This is what I'm looking at. When the API is almost complete, I should be able to deploy it in production sometime when the full history indexing is complete. But I'm thinking of this. So this is, let's say, this can be transaction type. So you can select your transaction type and a full text field where you put in your account address. And let's say this can be amount. Amount is between or equals to something. This is greater than, but you can say less than equals to, and you put a number. And this way you can build your own query. Instead of writing the JSON DSL, the way we saw it, it should be easy to just build using this.
I mean, if it's already Elasticsearch, have you tried already just putting Kibana in front of it?
I did, yeah. I did try. Kibana provides nice dashboards, and you can build your query and just save it right now. It is, I am hoping it's an open source project and folks will be able to query Elasticsearch directly, and Kibana is just a Docker install away. Put in the username credentials and you can create your own dashboards in Kibana.
So I also have a question. So if you want to introduce an API for it, right? Then I assume that you need some resources, and also there's going to be a lot of API requests. So are you planning to add some API limits or monetization to it?
Yes. It should be good to have, yeah.
Yeah. So yes, that's
yep.
Perfect.
Although protecting the API from abuse would be a challenge. Right now, all the XRP scan APIs, they are public, and there's Cloudflare in front, which it has some security provided, so it.
But it's going to be a lot of data, right? And the query is going to be so expensive.
Yeah.
And imagine it's going to be so complex query, and it's a lot of resources.
Yeah.
You need to be able to have a really strong resources for this.
I agree with you. Yeah. Mm-hmm.
Hey, just wanted to say thank you for this. My question is, where can we find the API? Is it through XRPL Go, or is it a different location?
So the project is open source. I'm hoping that anyone can run this in their own infrastructure, and if you have access to full history, just index it. And there will be a public API, but again, as Ali mentioned, it will be prone to abuse because there are some queries can be complex and can lock the instance for a few seconds and prevent others from querying. So it will be a trade-off between running in your infrastructure or querying the public API with API limits. Although the API which I showed you is an Elasticsearch API. If you are aware how to publicly expose, you could run it on your own. But it's a REST API. JSON goes in, JSON comes out.